I'd probably flip it to
Excellent.
like gallery view.
So what we would like to do is see if we can't troubleshoot console in our application, speaking to console and sometimes receiving no response. Or is it no response or that we're receiving a response that's empty? Looks like no
So
response.
this is a fun one. So what we're seeing is actually that the connection was made, but there was no response given in time.
Okay.
So we're not getting an empty response back because then we would get a different error message.
Yep.
Um, you have a series of error messages. You can get an actual failed to connection, right? So you get a connect to, no route to host, or connect timeout, right? Then you get the no response, which is where there's literally nothing came back across the pipe. And then there's effectively a no, which is a no answer was given.
Yeah. So it looks like in your latest message, no route to host, that could be a few things.
Right.
And that would require us to kind of dig through logs to find a correlation of a scaling event or a pod rotation event. The other one that it seems that you want to concentrate on is
That failure to
we're receiving a
respond.
TCP timeout, it appears.
Right. Which, based on what I saw, noting that I watched and read the notes from the call this morning, yay, double speed. Um, what I'm seeing is that on occasion, console has a message that the client disconnected.
Okay.
Right. Um, my guess in that regard is that console did not respond fast enough, so the net DNS resolver reconnected and tried again.
Yeah.
So in the message I have from 10 a.m. Eastern this morning points out that there's the two types, the ones that we really care about, which is the no response from name servers list. There is an instance where we were getting more than one actual error, but we're swallowing it. We fixed that since, so now we get a
Yep.
no response from DNS servers when we try to look up the DNS server that we're supposed to be asking.
Yep.
So that problem is out of the way. We can identify that now. We now know that almost every single time it's truly that there's no response from the name servers list provided to NetDNS resolver.
Yeah.
That means that we're connecting and then there was no response in time and it cut the connection because it was like, somebody should have responded by now.
Yeah.
There are very rare no route to hosts. Those appear, based on their sparsity, that it's either pod scaling or node scaling,
Yeah.
right? Almost always, what I'm seeing are the no route to hosts are trying to reach out and hit the actual DNS server, like the kube DNS, and it goes poof and it goes away. I need to verify this, but it appears that that's what I'm seeing. I'm not seeing it getting a no route to host to connect to a service IP. I'm seeing it get a pod IP.
Yeah.
And then,
I find that a little strange because we're sending it to the service address because we're using that DNS address for the service so that we know how to reach the console.
right, that's why I'm saying I don't think that's particularly the case.
Yeah.
I think that failure, that connect to no route to host, is actually a problem reaching kube DNS because it's scaling up or down based on their scaling methodology.
Yeah.
Google has something a little funny for their kubeDNS autoscaler. Um, I don't think that's us because we would have a consistent IP address.
Okay.
And that is indeed where all of the messages that we're going to talk about here in a second come from, is from one locked service address.
Okay.
Um, so almost all the time, it's like poof, something went away. And as a general rule of thumb, a service, so long as the service is present, will have a service IP.
Yep.
No route to host you'll get a route to that host. What you won't get is a connection. The connection will
Yeah.
time out trying to connect. You'll still get a connect to error, but it won't be no route to host.
Okay.
So on my hunch of the no response, meaning that there was actually a timeout somewhere, I went looking in the logs and just took the same sector, the same base selector and time zone, and looked for anything with timeout, and then realized, oh, look, here's a very nice clean message from the warn log out of standard out that not responding within TCP timeout. I'm going, I will bet you that correlates. And so I picked a single pod, Kubernetes dot pod underscore ID. So I just picked a particular pod ID out, and then went, give me, the last day with this message or this message. And I just kept cutting it down to the smallest window to show replication of the events.
Yep.
And what we end up seeing is every time that we get the message, no response from name server list, you can see the underlying net DNS trying to connect, timeout expires, try it again, try it again. And I'm like, bingo.
Yeah.
Now at least we have a point in correlation that we can try to use.
And we've only got one name server in this case. Like there's only one service exposed, so we've only got one IP address that we're ever going to hit for this. So there's not going to be a next one for Ruby to try.
Right. So that's the finicky part here. Because the way that we're doing our GitLab database load balancing resolver only pulls the first answer. Now, in theory, that should be the service IP address. There are ways with kubedns to make a request and get all of the IP addresses of all of the services currently backing the pod, and then you can walk down it. We've seen this in some experience in dealing with Nginx.
Yeah.
Right. You get the endpoints back instead of a particular individual IP or the service IP doing the proxy result.
Yep. Yep.
So what ends up happening is we resolve the name server's name, aka, hey, kubedns, where is this console service? Right. DNS console DNS.console.service.cluster.local, I think. And that will return a single IP address. And if it returned more than one, we're discarding it anyways right now. Yeah. So this is kind of one of those scenarios. From that point, assuming that the IP that we have logged there is the current active console service IP, then all the traffic is going through that, but then the service routes it to a given pod that's live and marked ready. And then that pod is not responding within the TCP timeout that is set by Ruby's net DNS resolver.
Yeah. Do we
Question
know
is,
what that timeout is and if that's configurable by us at all?
on the button is, where is it coming from? What is the expectation, and how far out of that SLA are we?
Yeah.
Okay, so also mentioned, I'm going to tangent just for a second. Also mentioned earlier was the concern that the current expectation of Consul's chart, or just Consul and Kubernetes, is of question just because it's newer, or that HashiCorp themselves may not be fully familiar with handling a service like that in Kubernetes. I don't really know what's going on there, but I'll admit I've kind of gone, why do we have a daemon set and then access the service IP? That's a fun one. That can somewhat be controlled via external traffic policy. But saying that, it's also somewhat logistical to point it at the service IP rather than the daemon set, because instead of trying to connect to the daemon set and knowing that the pod has an IP address and you don't know if Consul's there, it's entirely possible for a given Consul client on a node, then you could have a node that's out. So if you're accessing the local copy of Consul that's not currently a member, then you're going to get no response, and every single pod on the node is not going to respond or not be able to operate correctly. So there's that kind of trade-off. Now, one of the things that's more expected from their documentation and their chart, from what I can see, is they expect that you shim or stub the Consul domain into the actual kubedns or the core DNS that's implemented in your cluster. You basically convince it to send anything that's, service.consul to the Consul service IP address. Now, there's an upside in that regard, in that, even if the TTL is set to 1 second, if you get 10 requests in 1 second, Consul's not trying to answer that request for all 10. Right? Let's just say, as an example of, should we scale plus 2 nodes, and both of those nodes will happily fit 20 web service pods? They won't at our scale, the nodes, but let's give it an example. If there's a sudden scaling event, the pods will come up, and they will probably come up before the local daemon set Consul has actually joined to Consul cluster, right? Neither of them are members yet. So we need to ask the service IP. The service IP gets run through a kube proxy, which then routes it to a pod somewhere, be on another node for sure, but we don't know how far away. We don't know any of these things. The 10 pods come up, and their dependencies run pretty quick, and then they all try to fire at once. And they're going to be within a second or two, generally. Then you've got the problem of, boom, who do I get? Do I actually end up spreading the service requests, like, to the service IP? Are those requests being spread across the other 8 members of the cluster that are active and members? Or is one of them just getting hammered all of a sudden? Right? Service IPs that do load balancing are not necessarily load balancing. It's the first thing to keep in mind. Kube proxy service IP is not a load balancer. Round robin, maybe. Can we configure that? Can we convince that? Can we define exactly how it's going to behave? It's a good question. The next question I actually have to toss out there is, why are we running Consul in the cluster? Because one of the things we could do is actually create basically an external service. We have a service that reports back with an external IP address, thus actually pointing to an external Consul. Do we need to have it inside of the cluster? I mean, does that make sense if we can't resolve this quickly to bother to keep trying to run Consul in cluster?
I don't remember why we added Consul into our clusters. But I know we did that prior to us migrating any Rails service into our clusters. Like, we ended up making it a requirement. So I wonder if I could find out why. Because I can't remember. That was so long ago, and Jarv did a large portion of that work.
Okay, well, let's table that one for a second. I just wanted to raise it so that I don't forget to ask.
Yeah.
So let's see if we can figure out if there's a correlation between one of these points in time and a scaling event on Consul, or if there's a client hung up at about the time that we saw a flurry of TCP timeouts from the Rails side.
Yep. Okay. So if you don't already, here's a link to, this was this morning's agenda. I'm just going to reuse it. So I just added your question as the very first item that we can revisit later. All right.
Looking for the right term for the service external.
All right, so using the query that you had posted in the issue, clusters C and D haven't suffered anything in the last 5 hours. Cluster B has a sporadic set of events that happen at 1400 UTC, again at 1430, and then 1630. So like 10 minutes ago, roughly. I'm tempted to make this slightly easier and just target on one of those time zones.
Right. And that's why I had taken that screenshot of like, here's a specific time zone we can look at.
Yeah. So how about we try to focus in on 1632 is when I see only 3 events. So we get the no response from name server list, and we see 2 events, both saying name server, this IP address did not respond within the TCP timeout. Try the next one. So let's figure out if these were the same pods that were doing that same request. Pod name HFCS2. They are the same. So are these log messages STDO? It's the exact same log message. Different time, perhaps? Looks like the same. Looks like we just duplicated an event at the same time for some reason. So we know we had a pod struggle to make at least one request. So let's look to see if we had any scale events near that time for console pods. Or maybe some pod restarts at that time.
Right. Either that, because it could be console pods, it could be the nodes scaling.
Yep. I'll check the pods first.
Parallel, I am digging into the ability to understand and control the timeout from NetDNS Resolver.
Okay, interesting fact. Occasionally, the readiness probes will fail in console. So let's narrow this down though. Whoops, wrong button. I think I just broke Cabana.
Yeah, the interface is a little odd to me sometimes too.
No, it just completely blew up. I did confirm that the IP address that's showing in the log search that you posted, that is the correct cluster IP address that is utilized by the Consul DNS service. Not sure if that provides you any comfort, more or less, but
That's good. We know that we're getting the right IP address, then all the requests are going to the same place.
yeah.
And we can see that they are indeed retrying twice. And then when they don't have the response, then that's when you're getting back the no response from name servers list. I have found the default is 5 seconds. So console isn't responding to a DNS request within 5 seconds.
That's a little suspicious.
Wow.
So I'm still trying to get our logs going to see if there's any pod scale events around that time. Okay, so we failed at 16:32:09 UTC. At 16:32:14, we had a readiness probe mark a failure on one of the console pods. Space, let's do this. Which would, so that was at 16:32:14, so that is just 5 seconds after our failed request. I would assume that we're going to log in Rails after the timeout occurred. So that would have, assuming a 5-second timeout is not being overridden anywhere, that request should have made it to the pod at like 16:32:04. So I guess what does the readiness configuration look like for this deployment? The readiness probe runs a curl to localhost. Its failure threshold is 3. Its period seconds is set to 10. That's so it runs every 10 seconds. And its timeout is 1 second. So if this command fails to run within a period of 1 second, we'll fail the readiness probe. We only failed the probe once. And assuming our timestamps are all in a kosher standpoint here, it looks like we could run. We will have failed. We could have a pod in a failing state, receive a request, the request is not met, and then the next readiness probe is sent to the pod and fails. So there's the possibility this pod was in a failing state prior to that. But we only failed the event once, so no actions occurred on this particular pod at all. Let's see. So since we did have a failure in our readiness probe, I think the next step will be to concentrate on maybe this particular pod potentially and see if we could look at the logs. I know we're not capturing them, but maybe they're still inside of the pod because this was
Maybe.
not terribly long ago. And the pod should not have been restarted because we want 3 failures before we bring the pod out of rotation. So which pod is it? TGSCM. Yeah, running, no restart, so that's good. Over the course of the last 8 days, the readiness probe has failed 1,302 times. It's never been restarted.
What is causing this failure? Because that's a lot of times in 8 days.
Well, the timeout for the curl request is 1 second. So like, I don't know why we're failing our readiness probe, but that's a very short window of opportunity. So let me see if I could look at the logs for this pod. Last time this pod was started was March 23rd.
Do you have a time for that?
23, 23, 28.
Thank you.
Let's see. Let's filter out info. The only log message outside of I'm filtering out informational messages. The only thing that occurred at the timestamp closest to where we failed our readiness probe is a refuting of a suspect message from one of our virtual machines. But we see that quite often. Like that's the dominant item in our logs.
Huh. I wonder if we would be able to.
We document which pod we're targeting in this research.
Because if a message refutation comes in and then blip, it goes off. Is that resulting in whatever is causing the 1 second curl timeout to not pass? Or are we seeing a CPU spike while it's processing some sort of event or other network traffic? Is there, like, there's got to be something correlative that we can find to why this is happening? I know that we see these, refutations happen, but like if it's constantly refuting messages from the VM fleet, then like we need to figure out why we're consistently getting these refutations, because it shouldn't be happening all the time.
Let's do a quick count. So grep refute WC. Nope, because it's refuting. So still excluding, I don't know what's in info logs, but excluding info logs and counting the word refuting 5,600 times. Wait, is that the right line number? Yeah, 5,625 times refuted a suspect message from some machine. And this varies. Like around that time was specifically a VM, but I also see this for GKE nodes as well that are participating with Consul.
I just popped up a console chart. There's a laughable comment in here for the readiness probe because we do this curl exec, and then we turn around and like hit localhost on the specific port or whatever else.
Yeah.
There's a note that says when our HTTP status endpoints support the proper status codes, we should switch to that. This is temporary.
So we're running a really old version of the Helm chart. I don't know what version you're looking at, but I feel like that comment probably exists for quite a while. If it means anything, we're on version 020.0, I believe.
Okay, well, this is 031.1. So yeah, it's still there.
Okay.
I will pull down the version that you just said.
I did capture that somewhere. Not in this issue, but I did capture that somewhere already. So we know that nothing happened to the node itself. Like it's not a node scaling event. We know the pod has not scaled. So maybe the next thing to look at is metrics for that node to see if we are suffering maybe a high usage of CPU or memory for that node that this is operating on, and maybe also for this pod. Like maybe this pod was suffering from unfortunate event. So where in our logs is the node that we're running on? So this is the target node that we want to look into. Let's see if I can't first find that node at our own Kubernetes dashboards.
Where did you get that 1 second timeout from?
I will copy and paste the configuration of that daemon set into this document.
Okay.
I just copied and pasted it. Feel free to push that where you want. Whoops, crap. That's not what I wanted.
Okay, so my only problem is that, at least according to the version that you mentioned, doesn't have those properties. So you may have it
Interesting.
set, but it doesn't seem to do anything.
What do you mean?
Like I'm looking at client daemon set. I'm looking at the rendered template for it. And there is no template that has any control over the readiness probe's behaviors. Like the only thing it has is TLS enabled or not. That's it.
Interesting.
You said 0.20.1.
Let me double check that. But I'm pretty sure that's what we're running.
Yeah, even in 0.31.1, there's still no control over the readiness probe timeouts. Anything.
It's just hard coded.
It's whatever the server's default is because it's not otherwise specified.
Oh.
Yeah.
Interesting. Okay.
So
we're using the
just
Kubernetes default for all this.
Yeah.
Ah, okay. Let me still just double check what version we're running. Console. We're running 0.20.1.
Okay. So yeah, I'm definitely looking at the right one.
Yep.
Yeah, those settings don't do nothing.
I mean, they'll do something. We just can't modify or change them right now, right?
Right. Like, no, you misunderstand. The values that you have present here appear to not be rendered in any fashion, therefore have no literal effect. So they do nothing. You can provide them and Helm will know about them. They just will have no impact whatsoever. Now, if this is the rendered content, like if you're looking at it from K9S or whatever.
Oh, I pulled this out of Kubernetes.
Okay, then yes, this is entirely defaults from the particular Kubernetes deployment.
That's good. That's interesting information.
So the question here will end up being 8501. Okay, 8501 means TLS is on. Good. In that particular case, we should be able to replicate that exact pattern and on a regular basis and watch for pods that are having problems responding within the 1 second. This is a particular instance where we should really have the ability to tweak this.
Yeah, I agree. Okay, so here is the chart or our metrics for that node itself. So we could see that CPU usage, the CPU load is high-ish. So we're definitely getting our money's worth out of this node. Like CPU utilization is hovering around between 50 and 75%. We're not using very much memory at all. There was a flurry of disk activity just prior to this event.
How much you want to bet there was an uptick in pods?
Potentially. That's primarily what I wonder about the disk utilization. But I also note that right around 1630, our metrics kind of disappeared for a second on this node. Some of the metrics disappeared for some reason.
Interesting.
I don't know why some of our metrics would disappear and some would not, though. I'd have to like dig into which metrics and where those are coming from to figure that out. But that disk utilization that propped up is like short. It's a very small amount. Network traffic, you know, it bounces around, but it's not horrible. So let me shift focus and look at the metrics associated with that pod. TGSCM. So here is a link to our node dash board. And there's only one container in these pods, and that is Consul itself. We don't have anything else running. But if you look at our pod metrics that we're gathering, like memory usage didn't budge. CPU, like these are very small numbers, 0.01. I don't know if that's a percent or if that's like the usage in millicores. And network IO is very tiny.
Right, but we're looking at that apparently just console. We're not looking at all the load on the machine itself. Could it have been the machine had been congested at the point that console wasn't guaranteed?
Good point. I
In
would
that
hope
regard,
not, based on
are we
that.
using guarantees on the QoS for console's memory and CPU as opposed to best efforts? Guaranteed are limits and resources, requests and limits that are defined and identical.
I don't believe we could figure that at all.
Okay, console does this as a matter of values.client.resources, and then they run TPL on that content. Check the
We
defaults
do
for
not
that.
we do not configure any resource requests nor limits. What's the name of that item, like pod class?
Resources.
Yeah, resources is an empty block.
Okay. So that's what they actually have set as well. So you're getting whatever GKE just happens to default for a best effort non-guaranteed result.
Yep.
I'm going to say that's probably one of the first things we want to do is guarantee its CPU time.
Yep. I thought we had metrics for like throttling.
Well, can we check the CPU usage on the node on which this pod was living at that particular incident time?
Look at, I have a link to the node dashboard. That's the node in which this pod was running on. Sorry, I'm changing our font size in this document. Oh, is that what happens when you click on it? Oh, I see what you're saying.
Okay, so the particular point in time we're looking for is why this roughly this 1630 gap, right?
Yeah, 1632.
Okay, I'm gonna zoom mine in from 1629 to 1633. Yeah, there was a distinct load shift. For about a minute, where it went from the average load of 25 to 133. What happened at 1630 and change?
Well, if you zoom back out, those spikes happen very often.
What
But yeah, we should,
happened?
we should figure out what happened. Yeah.
Because I mean, you can look at the exact same time frame. Now, mind you, we're not super in here. I don't. It's running on 30-second intervals, so I don't have it any
Yeah.
closer, right? Um, and I don't know that we can adjust it to a smaller interval, but unquestionably, an average per core load of 120%.
Pretty significant.
And if this is regularly happening, we need to understand this behavior pretty badly. And this definitely tells me that Consul absolutely has to have specific, defined, matched requests and limits so that it gets guaranteed CPU time in the middle of this. Because there's a massive spike in disk activity, and then the disk activity trails off, and then CPU goes boom. Did a deploy happen?
No deploys today, so far at least.
What would cause such just smash goes the disk, and then immediately afterwards, smash goes the CPU?
I'm trying to pull up our logs from this node around that time.
Because I'm not seeing any real change in inode usage. I'm going to jump out a bit from 1600 to 16, just to 1700 then.
Oh, goodness.
Yeah. Oof.
Well, even I'm looking at our logs and there's not really much happening. I might need to go elsewhere.
Now this node is or is not part of the fleet handling sidekick.
This node is handling GitLab shell.
You're deploying more than shell though.
On this particular node pool, no.
So
Like we'll have Fluent D and Elastic or like pub sub, but like as far as what we want to run on this node pool, it's just going to be GitLab shell.
So just that container, no other Rails API, no nothing.
Correct. Is there a fancy query I could do to get all pod? Well, I know I could grep. But is there a quick way I could say, hey, give me all the pods that are running for that node in K9S? Well, I'll just do a grep.
You can actually just pop over to nodes, go to that node, hit enter, and it'll give you the description, which will show you all of the pods running on it.
How do you go to the nodes? Here, I'll share my
nodes.
screen. Shell. Let's see, and what node are we looking for? We want shell 233E34 F8 dash DV5S. And what's the key combo to show me pods?
Just hit enter or describe, which is D.
Yeah, so as you see, there's only GitLab shell. You know, here's our pod that we're investigating. So only GitLab shell, a bunch of stuff that Kubernetes or GKE provides us, followed by our logging infrastructure and our node exporter that we manage. 45 restarts for that node exporter. That's great.
That's not our node exporter, is it? No.
This is the monitoring provided by the infrastructure team.
That's what I thought.
So there's not much running.
Okay. So
Oddly.
Yeah, I definitely want to do some investigation to what's generating these massive spikes on average per core load. Like it's good that we're using it, right? Don't get me wrong. But when you can just kind of trace the line average and you're below 75%, but you're regularly spiking over 100,
Yep.
Like there's a problem here. And we should at least understand what's happening and the expectation of what will occur when that happens.
Yep.
Okay. So one discovery is that we should definitely be setting resources.
Yes, I would agree.
That could definitively explain why we're seeing transient timeouts. Is if Consul is just being shoved out of the way. It's nice is too high.
Okay, so look at that chart for me. Expand your view a little bit.
Still on the node, correct?
On the pod, yeah, on the node.
Okay.
So 1632 is when the first readiness probe fails in the window of time I'm looking at.
Okay.
That same readiness probe failed again at 1636.
Uh-huh.
And at 1638. Do you see any load spikes during those two times? Or during those 2 other times?
Let me grab the usage per. Can I? You gonna let me? Trying to relocate the dashboard, but 1632,
1636, 19.
1632 massive spike. There's a 100% usage, just over 100% usage spike at 1635.30. And then you said
1638.20.
there is a peak. So it goes at 1638. 1638.30, it's 42, and then it immediately shifts by 1639.30 to 77.
Okay, so we have something that is impacting load very close to the time in which console begins failing or showing signs of failure.
Yeah.
It's weird though that it's only one readiness probe that fails out of these 3.
Well, note that we don't have anything finer grained than 30 seconds here.
Yeah, yeah.
So the likelihood is that we may be seeing it not actually doing a full swing, right? We could be going from 30 to 200 and back, but over that 30-second time, it's, didn't crest all the way up there.
Yeah.
So the thing is, if like I'm looking at a 1 hour window right now. So let me share that window alone. There we go. Let me know if it's doing the flicker. But I have just 1600 to 1700. And
Yeah.
here's the 1630 spike on the system load. And then if I go over here, the 1630-30 on the CPU average. So 30-30, 30-30.
Yep.
35-30, 35-30. Right? And we see these saw teeth happening. And they almost correspond to the per core usage.
Yeah.
And then when we look at the total CPU utilization, that doesn't necessarily align. But what that tells me is something is literally choking out a couple of cores. Right? Like how can we hear at 1630-30, right? So 1630-30. The CPU utilization is 67%. But the system load is 133. Now, how many cores are in that box?
Should be 8 if I recall. I could look that up. In fact, let me just do that. That way I'm not guessing.
I mean, it looks like it's 8 according to what I see in the next one over. But like
Yeah.
most of the time we're in the, 40 to 50-ish range, which is okay. But, when you 150% higher, 133% or whatever, right? We go from a load average in the 60s to 133. That's plus 120, 130%. It's pretty rough. So there's something happening
N1
on
high
the cycle.
CPU 8s, which provides us 8 CPUs.
And that's the interesting part. Is look at this: 1530, 2030, 2530, 1630.
You know what that correlates to? That's like almost at every minute or every 5 minutes. That's like cron jobs of people doing Git requests, probably.
It might be. All
Maybe
the
when
more
we're
reason
syncing
you should be
repositories.
guaranteeing console service.
Yeah. What I would love to know is if we have a dashboard that tells me all the resources that are on a specific node. Looks like we do. Because that might help us determine what's going on with this poor server.
Okay, so I don't want to dig too much on this one. We should note, like, we need to go look into the usage behaviors of GitLab shell and these apparent spikes every 5 minutes. Like, this might
Yeah.
just be the usage, which is cool, but we need to know, we need to be prepared for it. And we need to guarantee that, SSH can take a little longer. That's fine, but we got to make sure Consul stays up.
Yeah.
Right? So if that's happening here, then the next question would be, what happens if Rails ends up querying this console? Right? Then Rails can't start new pods or can't get load balancing to resolve who the current host should be because shell is overloaded.
Well,
seems weird.
You might find this interesting. I'm going to paste a link for, this is our workload on the node dashboard. We're going to suffer the same issue in looking at this where our resolution is kind of low. But nothing really terribly sticks out. Like the CPU usage of all the pods that are running is relatively flat.
Right, which tells me to some degree that there's definitely something happening on that regular basis.
Yep.
Like we should see a correlative flood of requests from the shell fleet to the API on that 5-minute cyclic pattern.
Yeah. I was kind of hoping to see that in this top chart of that graph where maybe GitLab shell was getting some pressure on that cycle, but I'm not seeing that on this chart.
Okay, let's circle back to shell's behavior. And let's go see if there's anything else we can find on a non-shell pod. Or non-shell node.
Let's see. I kind of want to pick a node that still suffers from this issue, or at least that we've seen this console error from. There's a server that runs our Git fleet that we could probably look at. All right, so I'm looking at another server. In this case, it's a server that manages or runs our Git fleet, where we had a usage spike of some or a failure. Here, I'll share my screen. This one. So here, no response name servers list. This happened at 1401. So similar behavior. I guess what I should do is make sure this is the same exact server. Where's the node name? Here. So this is the same node, and this happened a few times. So this event happened at least 2 times within the 1400 range. If I go look at the workload on that server at 1400, like the load is relatively similar, hovering at 5. CPU usage is kind of bouncing all over the place for each core. These machines look like they have 16 CPUs. Memory didn't change at all during this time. No disk
you can definitely
activity
see
at this
Rails
time.
spawn.
Network activity was on the drop, in fact, but still reasonable. Let me go back to this one. What was the name of that server again? D2. This one. Whoops. If we zoom in closer to 1400 here, like the dominating services are the Git pods. Like nothing, just nothing looks terrible or out of the ordinary in this case.
Okay, so then it does really seem to come down to wherever that particular request ended up going, whomever it ended up at, and I don't know that we have a way to trace that, to be honest, did not respond within that time period. Sorry about the random Jake break in the middle of that.
So I've got a merge request open that will hopefully get us our logs into Elasticsearch. That way we're not peeling logs out of our pods manually. I'll proceed to do a little bit of investigations, but we should set our resource limits and requests to and get a merge request open for that. In the meantime, what else can we research or look into at this point? Like we definitely have some awkward usage spike, but I'm not really sure how to further trace that down at the moment.
Okay, so don't be wrong, we should know about the usage spike. Right now, my focus is explicitly on what can we do to mitigate the fault that we're seeing right now.
Yeah.
Do we have any task runner pods active? No. Okay. Can you check the environment to see any hosts that are exposed through env or env? Specifically, if anything happens to show up as an env entry for Consul.
I need you to repeat that question.
Okay. So every pod in Kubernetes has environment exposed when it starts. In that environment are all of the services that are exposed to its environment. I don't think Consul is going to be exposed through env because it's not within the same namespace. But it might be worth checking to see if there's an environment variable present within the pod, a web service pod in particular, that would actually have information about where Consul is.
I guess the best way to find that is just to run the env command inside of one of the web service pods, correct?
Yeah, you could just coup control exec env. Obviously, probably want to pipe that to less.
Yeah. I do not see. I mean, you're correct because it's in a different namespace. I don't see anything related to Consul in the environment.
Good. That's kind of what I expected, but it was just that off chance that something showed up. So now it comes down to the design and understanding what we can do to possibly change how Consul gets deployed and how we consume it. Okay, I'm going to have a look at the client service.
I guess while you do that, I'll start looking at some resource utilization to see if I can't figure out some sane values.
Honestly, my expectation is we won't need more than a couple of 100 meg. Like 100, like 200 megabyte of memory seems probably not needed. That's an easy one to find out. Just like grab all the Consul pods and see what their lifetime memory is. Boom. And I would say not. We probably don't need to guarantee more than say 300, 400. Like 300M on CPU, a third of one CPU is guaranteed theirs. Now, the downside of setting requests and limits identical is that you never be allowed to use more than one third of one CPU. But anything is better than whatever. I'm digging into the service behaviors. I'm trying to find something there. Hmm. So the only effective change that I see as available and what's currently present in the version of the chart in use is the ability to specify the cluster IP. If you specify the cluster IP and you say none, then you effectively get a headless service, which, because there is a selector present, means that you will actually, when you query the DNS, you'll get back all of the A records. That's the problem, right? You'll get them all back, and you won't necessarily know which way you get them back. And then you start having log entries that like say, I tried that one, and then I tried that one, and then I tried that one. That would be somewhat feasible if we could ensure that not all traffic is being directed to a given top of the list. And two, if our GitLab database load balancing resolver actually returned more than one entry, because it doesn't. So I don't think that's really something we can viably do.
Is there anything in there, and maybe this is a bad idea, but instead of having our pods reach out of that node in order to reach console, is there a host port configuration that we could leverage? And then we could somehow configure all of our pods to talk to localhost and some port that we know that console should be running on. Since we run console in all of our nodes anyways currently, that would eliminate network hopping.
That would, but as I mentioned early in the call, in doing that, in the event that a given node's console instance got kicked out, all of that node would be out.
However, if we set the priority class to a certain value and we set the resources as we should, because currently we don't, theoretically console should bounce back. And since we poll for console, every 60 seconds, I believe it is, we'll put pressure for that one node onto the primary database for that 1 minute in which all of those pods failed their request for. So hopefully if something like that happened, it shouldn't last but so long, assuming console was able to spawn back up correctly. Our blast radius of a failure is still limited to one node at that point.
Right. which is effectively, yeah.
And currently our pods are really spread out. We run quite a few nodes, so hopefully that's not a terrible deal. But
so that's the trade-off in that the target ports are known, and we know the ports according to the daemon set. They expose named DNS dash something.
Yep.
And basically one is TCP, one's UDP, and they're the same thing. So if I look at the daemon set, the containers are 8600 for TCP or TCP and UDP DNS. The DNS server runs on port 8600.
Yeah.
Inside the container itself. But without exposing that as a node service, which the DNS service console-dns.console.service. Yeah, so that's the one we're using. Does not have a way to expose this as a node port. So we would actually have to ourselves actually turn around and like write a service that allows it to expose the DNS service as to the daemon set when in use. So the TCP port hasn't changed in 031.1 of the console chart. I have to find the service though. Found it. It was just super hard to find. Okay. So they do expose type in 031.1, whereas they do not in 020.1.
So we need to upgrade. I'll make sure to note that because that might be an option we may want to explore further.
You may want to explore it further anyways, just because, let's see.
We're also using an older version of console. I documented, let me pull that information because that was fun. Like I haven't looked at release notes, but we're kind of far away. We're running version 172 of console, and the latest version of that Helm chart will pull in version 194.
Right.
So I mean,
default.
that in itself could be helpful.
Right. Well, are we running console 172 because we're aligned with the version that's in Omnibus, or just happens to be the version of chart we installed?
Good point. I think we're running just what comes with our Helm chart. I don't know what we have in Omnibus. I don't know how any of that's configured.
Give me a second.
But do we... I don't even know if we're running whatever we ship with Omnibus for console. I don't know if we set up a dedicated cluster for that or whatnot.
We're ship. Wow. 1610.
So we're already slightly newer.
Mm-hmm. All right. So I'm hitting my up against my hard stop.
Yeah.
So our console is out of date chart wise, but that means an application update, which might mean a compatibility update to versus what's in Omnibus. Are we using the Omnibus for our console cluster?
Need to find that out.
Okay. So that'll be the first enter because maybe it's time we tell Omnibus to update console.
Yep.
The change to make the service become a node port instead is not that hard. But there's some dancing to do on that one because you really don't want to try and expose port 53 on Kubernetes node unless you have to, and there's a lot of touchbacks on that one. I still kind of want to try, instead of I want to try and figure out how, instead of having us ask for where is console and then ask console, does it make sense to route the request through the system DNS, through kubedns, through core DNS in a stub domain? Because if anything else, at least then we would have, when you get 10 requests all of a sudden, it's not, hey, here's 10 requests, console, I hope you return, right? Like, yeah, I want to know why it took 5 seconds for console to answer, but I also kind of want to know, like, can we use a caching layer that is built into the DNS that we already have?
So console provides the mechanism to inject its results into kubedns.
Right. So basically, you configure kubedns to make the stub domain a forwarder. So if you ask for anything at .service.console, it gets forwarded to the console DNS service, and then you can configure how long it will cache the answer.
Maybe refine what I'm writing. I'm writing down action items.
I have it in the issue comments.
Oh, okay. Perfect.
I did it earlier. Don't worry about it. So I'd have to go digging into the load balancer, the GitLab database load balancer code base again to see what parameters we're passing to search and if the timeout configurability is there. I know that the gems default is 5. I have to see if our default is that, or if there's any timeout configurability that's beyond what's there. We can pass it a different timeout. We just have to make it possible.
I would also shy away from doing that. I feel like 5 seconds should be kosher enough for us to be operational, but
I generally agree with you.
it's a troubleshooting step, at least, you know?
Right.
Okay. Is there anything else that we want to touch on? Otherwise, I think we're ready to end the call.
No, I think we've explored just about everything we can, and we found a couple of edge cases while we're at it that we want to look into. So I think we're in a good state to having forward progress.
Cool. Excellent.
Cool. I'll catch you later.
Later, man. Have a good one.